some of this you guys should be familiar with from last year. The second part might be a little bit more challenging, finding the equation. Okay? How do you find the y-intercept of any graph? Yeah. How would you, okay, if I gave you a graph of something, how would you find, where would you find the y-intercept? Where it what? I need a little bit more than that.
The y-coordinate at the point where the graph passes through the
No. Come on. Somebody come up here and point the y-intercept to me. Just point where it is.
Right on the bottom.
Point, come up here and point where it is. Good. Okay. That's how you do it graphically. Just look on the graph, see where it crosses the y-axis. How do you do it algebraically? If I just plug what? You make x 0 and figure out what y is. Okay, that's how we do. So you can find the y-intercept by just looking at a graph, or if you're just given the equation and not the graph, if you're given just the equation and not the graph, then you make x equals 0, you solve for y. Where's the x-intercept or intercepts here? Somebody come point them out, please. Thank you. So, x-intercepts are a little different than last year. Last year when we did lines, there was only one y-intercept and one x-intercept, unless it was a horizontal or vertical line. But those are exceptions. This year with parabolas, it's a little bit different. There's always going to be a y-intercept and there's going to be one. But the x-intercepts depend on how the parabola is drawn. Okay? So here, if we go down to these questions, notice that you're not asked to find the x-intercepts just yet. You're just asked to find how many there are. And the way you do that is you sketch a quick graph. It doesn't have to be a perfect graph. Okay? And I'll show you when we do one. Well, you guys said for the y-intercept, we make x equal to 0, right? So we take the equation, we plug 0 in for x, and we calculate y, and what do we get as the y-intercept in this one? -5, good. The x-intercepts. All I want to do is sketch this. Where would the vertex of this one be if I sketched it? Does it move horizontally at all? No, because there's no parentheses. Does it move vertically at all? Yes, it goes down 5. So it does. So from 0, 0, it doesn't move left or right, but it goes down 5. So it's somewhere down here. Okay. Now the only other thing I need to worry about is, does it open up or down? It's positive here in front of the 1/3, so it opens up. Like, I'm not sketching it perfectly because remember, all I want to do is find out how many x-intercepts there are. And in this case, there'll be 2. Okay? So 2 x-intercepts. Try this again. So that's why when I said up here, we can determine how many x-intercepts are by just looking where the vertex is and seeing the direction of opening, whether it opens up or down. That tells me how many there's going to be, if there are going to be any. There could be a situation where there's none. Let's look at the second one. For the y-intercept, you got to be careful. You make x equals 0. So how are you going to figure out the y-intercept? Yes? Yes? Negative 16. Good. Okay. Now, the sketch. Yeah. Yeah, go ahead. There's what? Oh, that's not true.
Yeah, it is. The x-intercept is negative.
Get the vertex first. Does it move? Okay, remember we started 0, 0, but the numbers in there tell us to move it around. Do we move it left or right? Left, 2. So about there. Do we move it up or down? No, because there's no number at the end telling us to go up or down. So the vertex is going to be here. Does it open up or down? So it's going to look something like that. How many x-intercepts? Just 1. Okay. The last one. Y-intercept, we got to do some algebra.
Okay.
We got to make x equal to 0. So maybe we should do this in steps.
I agree.
Okay, what do I do first? Zero minus 2 gives me negative 2 squared. What is negative 2 squared? So this whole thing works out to 4. So I've got negative 1/2 times 4, and I still have to subtract 3. So that's the same as that. This gives me negative 4 over 2, which is negative 2. Subtract 3, which gives me negative 5. That's the y-intercept. That's separate. Okay. X-intercepts. Where's my vertex going to be? So about 2 to the right, 3 down. So somewhere around there. And it's going to open down, which means how many times does it go through the x-axis? 0. Yes.
I'm just confused, like, why don't we multiply with
What?
like, why?
Because it's subtract. There's no parentheses around here. Yeah. Better? Somebody besides McKenna, better?
Yes.
Okay. This one. Okay. Okay. Somebody tell me how to write the equation of vertex form.
No, yield bracket. Parentheses minus h parentheses squared plus k.
Good. Now, remember 2 things here. HK is the vertex. So if I know the vertex, I can plug the x coordinate of the vertex in here, the y-coordinate of the vertex in here. If I know a point on the line, xy, any point on the line, I can plug the x-coordinate of that point in here, the y-coordinate of that point in here. If I know these two things, and if I plug all those in, the only thing left to solve for is A. Okay? When we make an equation, if you're given the vertex, you know H and K, but we don't know A. We have to figure it out. Just like last year when we did equations of lines, we had to figure out what the y-intercept was in order to write the equation. It's kind of similar to that. So let me show you. And there's a couple ways that you could be presented with a question. It could be just in words or it could be a graph. You need two pieces of information. You need the vertex and a point. Doesn't matter what point it is, but make sure you actually pick a correct point. Like, don't pick something up here because that's not at the intersection of grid lines. So what's the vertex?
5 and -4.
So that means I know that H is 5, K is -4. Now I need a point.
2 and -1.
2, -1, sure. Which means that I know an X and a Y. If I plug all those into the vertex form equation, I can figure out what A is. And if I know what A, H, and K are, I can write the equation. So I'm going to use this form, and I'm going to plug in everything I know. Well, Y is -1. A is what I'm trying to find. X is 2 minus H, which is 5, squared, plus K, which is -4. I've just created an equation to solve for A. So now we go back to our equation solving. We got to get A by itself. Well, first of all, I got to do some simplifying. What's this? 2 minus 5? And -3 all squared? -9 or +9? 9. So A times 9, or 9 times A, 9A. Okay. Add 4 to both sides.
3 equals 9A. Now we're going to divide both sides by 5.
We're going to divide both sides by? No, by 9. So we get A is equal to 3 over 9.
All over 3.
So now you're ready to write the equation. You don't put anything in for y and x when you write your final answer because y and x represent any points on the equation. So I'm going to go y equals A, which I just found to be a third, x minus h, which we know is 5, squared minus 4. Go, find me that one. That's a new question. No, it's a new one.
Oh, okay, boy.
I want you guys to practice this. Show me that you know how to do it. So this time the vertex is -2, 3. The point on the line is -1, 4. Yeah, so this one becomes plus inside the parentheses, doesn't it? So remember, when you're asked to find, when you're asked to find the equation of a quadratic function, you have to be given hk and an xy. Find a, and then you can write the equation. So in this example, h is -2, k is 3, x is -1, y is 4. If you plug everything in correctly, so y is 4 equals a, open parenthesis, -1 subtract -2. So it should be plus squared plus 3. That's what it should look like when you plug it in. Because remember, inside the parentheses, it's x minus h. And if h is negative, it's going to change it to a plus. I believe so. But remember, now you got to write the final equation. So we do this first. -1 plus 2 is 1. 1 squared is still 1. So a times 1 is just a plus 3. A is going to equal 1. Okay. Now you're ready to write the final equation. This is where you just write y and x now. You don't put the numbers in. You only use those numbers to help you find a. So y equals 4, 1, or you don't even have to put that. If you put it, it's fine. If you don't, it's also fine. X plus 2 squared plus 3. Well, that was, I didn't mean for it to work out to 1. I wanted to work out besides something else.
Plus 2 because we made it plus 2 or plus because originally it was negative?
Right, so it's x minus -2 plus 2. Yes.
I'm saying before it was negative.
Yes, but when you put it in with the other negative, it becomes positive.
Right. So when we do that, we should just like, what I'm saying is you don't use the original number. Like what I was going to do was negative. So we don't, since it's the new equation, you don't use the original. You know what I'm saying? No, right.
You use the original h and k. You don't use the original x and y.
Right. No, it's fine. So I,
Okay,